What's up everyone, welcome back to another episode of AWS tutorial, and today I'll show you how to build a message queue system on AWS. But before we get started, let's talk about what exactly a message queue is and how people use it in the real world. Using a message queue is a pretty common practice for things like calling center or delivery orderings because it typically preserves the ordering of the messages. So for example, for a calling center in a bank, so every day there are a lot of people calling in to ask questions about a bank account or other things. But you only have so many agents to take the phone calls. So typically the call will enter a message queue system and then they'll place you on hold, and the first person that calls in would get a phone call's answer first, and then the people who call later will get served later on. And that's what the first in, first out means. And the same thing happens for restaurant delivery systems. And today we're going to build a message queue system for a pizza online ordering system. So right now let's imagine that you are a small business owner that sells pizza to the whole town. And because your business is booming, you need to open 2 pizza shops instead of 1 to serve the whole town. They have the exact same menu, use the exact same ingredients, and make the exact same pizza. So whenever people from your town use your app to order the pizza online, they don't really care about which shop the pizza is coming from because they taste the same. So whenever they place the orders, you will just enter the message queue system, and then your 2 pizza shops will take the order from the queue system and then process them, make the pizza, and then deliver the pizza to the customers based on the address. And right now, let's imagine that, unfortunately, today one of your pizza shops is broken down. Let's say the oven is broken in shop number 2, so that one cannot make pizza anymore. And the beauty of using a message queue system is that it provides you a reliable system that can keep your flow going, even though one of the shops is down. Because right now, all the orders are taken by shop number 1. So you don't have to make any changes, and your businesses can still operate the same way, except it may be slower because you only have 1 shop to make pizza instead of 2. But the advantage is that you don't have to make any changes to the system in order to keep processing all the orders from the queue. You just have to focus on shop number 2 to fix the oven and then bring it back online so that you can make your pizzas faster to satisfy your customers. But at the very minimum, right now you can still have 1 shop to process all the orders. And in today's tutorial, we're going to simulate this whole process, this whole scenario that I just went through. So without further ado, let's get to it. Alright, so right now I'm on the homepage of the AWS console, and step number 1 is to create a message queue, and we're going to use SQS on AWS. So I'm going to type in SQS, click on it, and then we're going to create a queue. And now you're going to see that you have the option to choose which type of the queue you're going to use. You have standard, and then you have FIFO. FIFO stands for first in, first out. We're going to choose FIFO because it guarantees the first in, first out delivery, and then it will ensure that each message will be processed once and only once. For the standard one, I think it will try to do the same thing, but there's no guarantee, so we're going to choose the FIFO queue instead. And then we're going to give it a name. Let's call it pizza ordering queue. I think for FIFO it has to end with FIFO at the end. And then for all the settings, visibility timeout. So what the visibility timeout means is that once the message is picked up by a consumer, this is the time that it will remain invisible to other consumers. So after this time, and if the message is processed successfully by the consumer, it will be deleted from the queue. But if there's a failure in the consumer side, when it processes it, it will just go back to the queue and then other consumers can consume it. So let's just do 1 minute, why not? And then message retention time. So this is the time that the message will remain in the queue if no consumer picks it up and processes it. We don't need it to be 4 days, maybe like 1 hour, or I just do 1 day. And then we can just keep everything as default. Encryption, let's encrypt our message and then hit create queue. Alright, so it's done, and now we're ready to move on to the next step, which is to create a Lambda functions for our backend application and the 2 pizza shops. But before we can do that, we need to create an IAM role for them to use. So I'm gonna go to IAM role, click on row, and then create a new row. I choose Lambda. Next, I'm going to attach two policies to it. One is the SQS full access, and then the other one is the CloudWatch log full access. And then hit next. You can see that we have two policies here. Give it a name. I'll just call it pizza delivery Lambda row. Hit create. Alright, so it's done. And now we're ready to create the Lambda functions. So I'm just going to go to Lambda. So the first one that we're going to create is the application backend Lambda that takes in the orders. And then we're going to create a pizza shop number 1 and pizza shop number 2. Let's call it application backend. We're going to use Node.js. And then permission, we're going to choose the row that we just created. I believe it's that one. Hit create. And then let's go back to functions and create two more for the pizza shops. Pizza shop 1. Same thing, we're going to choose the row that we just created. And then let's create another one. Okay, so it's done. Before we make any changes to it, I'm going to make a few changes to the Lambda functions. So the first thing is the timeout. Because the default timeout for Lambda functions is only 3 seconds, I'm going to increase it to 1 minute because that's what we set as the visibility timeout in our SQS. So I'm going to click on configuration, general configuration, hit edit. I just change it to 1 minute 0 seconds. Hit save. And then the second thing is the concurrency. I'm going to change the reserved concurrency to be 1, just so that it will only process one batch of the message at a time. Otherwise, one Lambda or one shop will just take in all the messages all at once. So 1. And then lastly, I'm going to add the SQS as a trigger to this Lambda, to this pizza shop. I believe that is the one. I'll keep the batch size as 10 and then hit add. And then I'll make the same changes to pizza shop number 1. Okay, so now we're ready to move on to the next step, which is to write a code to simulate the process. Let's do the application backend first. I'm just going to write the code in the Lambda console because it's pretty simple. So the first thing we're going to do is we're going to import the AWS module. And then I set the region to be US East 1 because the SQS is in US East 1, and then our Lambda is also in US East 1. And then I'm going to define SQS client. Next, we're going to define the URL for our SQS. And it goes like HTTP s SQS, and then it's the region of the queue, which is US East 1. Let's see. Yes, US East 1. And then .amazon aws.com/ and then it's the account number. And then lastly is the queue name. So I'm just going to copy that whole thing. Alright, and then we're going to define a couple constants. One is the number of pizza shops. We have 2. And then let's simulate the number of orders that we're going to have from the people in the town. Let's just do 100. And then we're going to define a function here. We're first going to define a variable called order ID. We're going to start from 1000, And then we're going to define an array called records that we're going to have for the orders. And then we have a for loop where we're going to build the params for each of the order. The first attribute we're going to have is the message body. Remember that we have to stringify that because that is what the client is expecting. We're going to have an attribute of order ID in the message. And then we're going to have the order detail, I guess, what pizza the customer is ordering. I'm just going to do it random number here. From 0 to 20. Right? Typically, there may not be that many pizza types. Let's just do 10. And then just do the timestamp in terms of when this order is placed. All right, and then the next attribute is queue URL, which is what we define here. And then next, for FIFO queues, we need to specify a message dedupe ID. We are just going to use the order ID as the dedupe ID, and it needs it to be in the string format or string type. And then lastly, we need to have a message group ID because that's how we can have two consumers to consume the FIFO queue messages. Otherwise, it would just be processed one by one, one at a time. So we basically have two groups because we only have two pizza shops. And we're going to do it in an alternative way. Just do I mod number of pizza shops. And that should do it. And we're going to finally add the param into each of the records that we're going to process later on. And then we have the order ID increment by 1. And now we're going to send all the records into our SQS. And we're going to do that in a for loop as well. We're going to do an await because we're going to have an async function, send message. If there's an error, we're just going to log it out. Okay, so that is it for the application backend. And obviously we're just hard coding the number of orders and the order IDs and all the details. But in real life, you're going to build it as an API. And then you have a front end that call the API to place the order depending on what the real user is using it or what they want with it. I have a different video on how to build a serverless API. I've included a link down below so you can check that out if you're interested. So I hit deployed to save the changes. And then now we can write out the code in the pizza shop to receive the message and process them. And the same thing, I'm just gonna edit it in the Lambda console. So the first thing we're gonna do is let's just console.log log out the event body just to see how it looks like. And then we're gonna extract the order detail from the SQS message. We're gonna parse event records, and then we're gonna take the first one. It's always gonna be just one message in the body, and then we can just console.log log out what the order is. And then we're gonna print out something like making pizza. And then let's wait for 5 seconds because if not, it's just gonna process everything in lightning speeds. And we're gonna define this function. We're gonna take in milliseconds. I believe we just do a promise, I think, and then resolve. We're gonna do set timeout, resolve in milliseconds. Okay, I think that should do it. I'll hit save. Let me just add something like pizza shop number 1. making pizza. Hit save again. I'll copy the same thing to pizza shop number 2. Change it to pizza shop number 2. Hit deploy. And now we are ready to test this whole thing out. So what I'm going to do is I go back to the application backend Lambda. Imagine right now people using your app to order pizza from your shop. So this is the API that handles all the orders. And then when I hit test, it's gonna send all the orders to the queue system. And then shop number 1 and shop number 2 would process them and make the pizza and do the delivery. So I just do test. I don't need this. As event. Hit test. It's an error. Let's time out 3 seconds. But some of them was sent successfully. If we go back to the queue, the message queue, go back here, we should be able to see some of the message got sent successfully and some of them were being processed. In flight means it's being processed. And let me fix the timeout and do the send again. So do configuration. 1 minute should be enough. We go back to the code. His test again. Alright, so they were all sent successfully. Now if I go back to the queue, and some of them are waiting to be processed, and some of them are being processed by the pizza shops right now. And I think it's going to take a minute to finish because we pause each execution by 5 seconds and we have 100 messages to process. So I'm going to pause the video and then come back in about 2 minutes. Okay, so it's been a few minutes. I think it should be done processing all the messages right now. So if I hit refresh, it should be 0 and 0 right now. Yep, so it's done. So if I go to shop number 1 and number 2, they should both have the logs for the processing. So I go to monitor, view logs in CloudWatch. I'll do the same thing for shop number 2. So the logs here, if I click on it, I should see something like the order ID, the order detail and stuff. And then pizza shop number 1 is making pizza. And if we go to shop number 2, we should be able to see the logs as well. And there you go, you can see the order details. And pizza shop number 2 is making pizza. So both of the lambdas are processing the messages from the queue separately. And they process different messages from the queue. And as you can see here, each of them take about 5 seconds to process because we put the lambda to sleep for 5 seconds for each of the execution. And I think the same thing happened here as well, 5 seconds. And now let's simulate the broken down of the shop number 2. So we can just go back to functions and simply just delete shop number 2. Okay, now we only have one shop being operational right now and we did not make any other changes. And now let's go back to the application backend and we're gonna hit test again. It should send 100 orders to the message queue again. Alright, so it's done. And now if we go back to the SQS, hit refresh, we should be able to see some of the messages are waiting to be processed and some of them are being processed by consumer number 1 right now. And I'm gonna pause the video again and then come back in maybe 5 minutes because we only have one shop processing the orders right now. Alright, so it's been a few minutes, so we should be done processing all the messages. So if I hit refresh, alright, so it's all done. And now if we go back to pizza shop number 1, go back here, and that is the new log. So if we click on it, we should see all the messages. And each of them takes about 5 seconds to process. And you can see the same thing here, the record that looks like this. And then the order detail that looks like that. And it says pizza shop 1 is making pizza. And as you can see, even though pizza shop number 2 is gone, pizza shop number 1 can still process all the messages without any problem or any modifications to the system. And that's how you can have a reliable pizza ordering system. And this is it, everyone. I hope you've learned something. And if you like this video, I hope you can give it a thumbs up. And I'll see you in the next video.